Welcome to the 11th International Conference on Climate Change, ICCC 2025. We are now in Parallel 1, Session 2. In this session, we will watch your Pecha Kucha presentation videos. Let's start with the first presentation, titled A Study on the Potential of Utilizing Mangus Rind as Natural Dyeing.
Hello everyone, my name is Siar Mantasa. I'm from the University of Queensland, Australia, and also Ministry of Public Works Indonesia. I would like to present my research entitled Replicating Partly Vegetated Emergent Flow Channels for Urban Reforestation. This is the hydrodynamics model. We know that the problem here is rivers in Indonesia, especially in urban cities, have concrete and it can create high intensity of sediments and also make the extinction of aquatic habitat. Besides that, it also degrades the water quality. The opportunities that we get here is we can transform our concrete rivers with the vegetated river, and before applying to the field we can model first, and we have a lot of laboratory data sets and also hydrodynamic model system to help us to visualize the condition in the field. It will be beneficial if we can create the models and apply the reef restoration because it can make the better water quality and biodiversity. Also, we can create flood safety, urban cooling, and recreation space, and also healthy rivers mean healthy cities. This research will be done by creating the velocity profiles model as the important key aspect here. By using the laboratory data sets from Devi et al. 2019, we can see here that we have partly vegetated channel, and we will model the velocity profiles using the system. Uh, the setup here is the baseline drag coefficient. We will use zero point 0.9 first, and the sensitivity test we will do the uniform scaling of the drag coefficient from 0.5 to 1.5, and the objective here is to match the velocity profiles along the vegetated film stations. What we get here is the uniform drag coefficient 1. Many velocity profiles not reproduce well, and uniform drag coefficient scaling is insufficient, and some stations require high drag and suggest larger drag coefficient or especially drag coefficient along the flume. When we get the model results better, we can provide evidence-based correction to hydrodynamic models and demonstrate the realistic velocity profile condition in the field, and also bridge the gap between laboratory experiments and also numerical modeling for vegetated channels. After we can complete the studies in the future, we can improve the parameterization of vegetation drags, a validated framework, and a basis for spatially varying drag mapping, supports the design of nature-based solution, and inform policymakers on how vegetation works in the river. Okay, thank you for listening my presentation. If you want to have further question or expand your connection, you can easily email me in here. Thank you.
For the next presentation session entitled The Impact of Climate Variability on Pneumonia and Tuberculosis Incidence, a case study in Surakarta. If you have any questions regarding the previous presentation, please kindly write them in the chat box.
Hello everybody, my name Nur Hasan Agung Prabowo. I come from Universitas 11 Maret. Today I'm presenting the impact of climate variability on on Pneumonia and Tuberculosis Incident, a case study in Surakarta. We know that climate fluctuation are a significant problem. As this diagram shows, temperature extreme as well as change in humidity can directly impair the body respiratory defense. This brings us to specific opportunity in Surakarta. We are observing a growing concern. Respiratory infection cases are on the rise. However, the link between these cases and local climate fluctuation is unclear. So, why does this research matter? It addresses a global health threat and the critical need for our health system to adapt, strengthen early warning system, and fill major knowledge gap in tuberculosis and pneumonia. Our aim to analyze the correlation between key meteorological variables like temperature, rainfall, and humidity, and the annual incidence of both pneumonia and tuberculosis in Surakarta over the 3-year period. We conduct a descriptive analytical study using public data. First, we prepare the data by aggregating monthly climate report into annual total or average. Second, we perform a visual trend comparison. And finally, we conduct a correlational and our findings were striking. For pneumonia, we observe a clear direct correlation as annual rainfall surged dramatically from 2022 to 2024. But the tuberculosis cases, we found no correlation. This difference is key. Our discussion shown that pneumonia is highly sensitive to extreme weather, but the tuberculosis, on the other hand, is not sensitive to the short-term weather. Its steady rise is driven by non-climatic factors. This leads directly to our final contribution. For pneumonia, we recommend that Surakarta Public Health Surveillance System integrate heavy rainfall forecast to anticipate and prepare for the surge. For tuberculosis, our finding confirm that the focus must remain on non-climatic intervention, improving case detection, contact tracing, and social living conditions. Thank you very much for your attention. I would happy to answer any question.
For the next presentation session, entitled The Dual Burden of Poor Sanitation and Climate Variability on Public Health, a case study of diarrhea incidents in Surakarta. If you have any questions regarding the previous presentation, please kindly write them in the chat.
Hello everyone, I'm Dr. Narulita Brilianti Fajirani Putri, a medical doctor from Indonesia, and in this opportunity I will be presenting our case study of diarrhea incidents in Surakarta and the dual burden of poor sanitation and climate variability on public health. Surakarta faced a dramatic 58.6% rise in diarrhea cases, and this surge wasn't random. It coincided with increasing waste accumulation, heavy rainfall, and warmer temperatures. Together, these factors exposed the city's fragile sanitation infrastructure and highlighted a growing public health crisis linked to climate and environmental stress. This crisis also presents opportunities. By integrating environmental health and climate data, we can design evidence-based policies for urban resilience. Collaboration between agencies can enable more coordinated waste management, water safety, and disease prevention. Diarrheal disease remains a leading cause of illness and death in low and middle income countries such as Indonesia. In dense urban settings like Surakarta, a breakdown in sanitation and drainage can quickly escalate into an outbreak. Beyond illness, these economic and social impacts are severe, so addressing this dual burden is a must. Our research used an ecological correlational approach to connect environmental variables with disease outcomes. We integrated 3 years of official data from authoritative Indonesian governmental institutions. This allowed us to quantify how climate stressors and waste growth interact to drive disease risk. We analyzed data from the year 2022 to 2024 using an ecological and retrospective design. Surakarta was chosen due to its dense population and rapid environmental change. We collected data on diarrhea incidents, rainfall, temperature, and waste volume from official agencies. Then we calculated annual changes and correlations to identify which factors most strongly influence the outbreak. We found a clear synchronization between climate and disease trends. Diarrhea cases rose by 58.6%, and rainfall increased by 713 millimeters, and waste volume grew by 5.6%. These findings confirm that disease outbreaks are not isolated health events, they are environmental outcomes. Strengthening sanitation without climate adaptation won't be enough. The study supports developing integrated urban management, improved drainage systems, and predictive outbreak models, helping policymakers act before an epidemic strikes. By quantifying the specific components of this dual burden and identifying areas of highest risk, this study seeks to provide empirical evidence essential for developing integrated, climate-resilient urban planning and public health interventions in Surakarta and similar metropolitan areas facing the same environmental challenges. This detailed approach will be vital for developing accurate early warning forecasting systems for diarrheal outbreaks in the future. And this concludes my presentation on this topic. Thank you for your attention and see you in another opportunity.
For the next presentation session entitled Hydraulic Modeling of the 2020 Jakarta flood induced by the record-breaking rainfall event. If you have any questions regarding the previous presentation, please kindly write them in the chat box.
Hello everyone, my name is Ahmad Warnais. I'd like to deliver a presentation about hydraulic modeling of the 2020 Jakarta flood induced by the record-breaking rainfall event. And I work for BRIN. Hello everyone, my name is Ahmad Warnais. I work for BRIN and I'd like to deliver a presentation about hydrologic modeling of the 2020 Jakarta flood induced by the record-breaking rainfall event. The 2020 flood was caused by record-breaking rainfall. Previous studies have several limitations. The use of daily rainfall data that doesn't represent sub-daily fluctuations, low accuracy of satellite rainfall data, outdated land cover maps, and the absence of east flood canal. RRI has several inputs. Early rainfall depth corrected rainfall, then cover data for 2020, reverse with the east flood canal and the best performing of dam, hydrosets, GLOW, SRTM, DMNAS, and PubDem. For evaluation method, flood inundation data were obtained from manual reports of BPBD, and model accuracy was flooded subdistrict detected by model divided by the total number of flooded subdistrict. For flood observation analysis, official reports indicated that the flood affected large areas of Jakarta and the affected subdistrict experienced the most severe flooding and recorded the highest inundation levels between 2013 and 2020. Model input, weather radar, heavy rainfall was observed over the southern part and propagated northeastward, and heavy rainfall occurred again over eastern Jakarta and developed over western Jakarta. Another model inputs, land cover of 2020 and rivers with East Canal, East Flood Canal, and hydrosets, Swabdam, Glow, Demnas, and Asertium. And only Glow was masked by water area. For flood simulation result, the GLOW-based model achieved the best performance, and the model based on GLOW, hydroset, and SRM predicted inundation depth exceeding 1.5 meters larger in extent than Lemnas and FABDEP. Compared with previous studies, the simulation using GLOW was able to reproduce a wider flood extent consistent with the observed inundation pattern. And for conclusion, early 2020 Jakarta flood successfully simulated.
For the next presentation session entitled Livelihood Vulnerability of Small-Scale Fishermen's Households to Climate Variability in Bengkulu City, Indonesia. If you have any questions regarding the previous presentation, please kindly write them in the chat box.
Thank you, ladies and gentlemen, for your time. I'm Gita Mulyasari from the University of Bengkulu, and I'm pleased to present our research entitled Livelihood Vulnerability of Small-Scale Fishermen's Households to Climate Variability in Bengkulu City, Indonesia. The core issue of the study is to analyze the level of livelihood vulnerability of small-scale fishing households to climate variability and the factors influencing this vulnerability in the coastal areas of Bengkulu City. This research was conducted in Bengkulu City, which was selected as the study area due to its strong relevance to issues of climate variability and the sustainability of small-scale fishing livelihood. Geographically, Bengkulu City is located on the western coast of Sumatra Island and directly faces the Indian Ocean. The respondents were selected using the accidental sampling method involving a total of 100 fishermen as the research sample. The collected data were analyzed using the LVI and a multiple linear regression analysis. The LVI IPCC value of 0.234 indicates that the livelihood vulnerability of small-scale fishermen in Bengkulu City is classified as low. The results show that the livelihood and daily activities of coastal fishermen are highly vulnerable to climate change and natural hazards, particularly those associated with marine dynamics and extreme weather events along the Bengkulu coastline. The central component values show variation across different types of capital. Physical capital is the highest, indicating that most fishermen possess physical assets such as boats, multiple fishing gears, and GPS devices that support their fishing activities. The sensitivity component show that the primary vulnerability of coastal fishermen in Bengkulu lies in their high dependence on marine resources for food and income. At the same time, health condition and access to clean water remain relatively stable and manageable. The results indicate that three variables have a significant effect, namely age, boat ownership, and fishing distance. Other variables, such as fishing experience and household size, do not have a significant effect on vulnerability. That concludes my presentation. I hope it will be beneficial for everyone. Thank you very much for your kind attention. Keep healthy for all of you.
Thank you so much for your attendance and participation. We will now have a 15-minute break. The next session is session 2, will begin at 3:50 p.m. Indonesia Western Time. See you after the break.